Today I'll be going over problem 10a from Euclid 2021. And before I go over it, I suggest you take a moment to pause the video and try this problem out for yourself. Okay, I'm gonna assume you had a shot at it, so I'll be going over the solution now. So right off the bat, let's just label some things. I'm gonna get a bigger diagram so I could label them. In the diagram, 11 circles of 4 different sizes are drawn. Each circle labeled W has a radius of 1, so this is 1. I'll use a different color actually. This is 1. Each circle labeled X has a radius of 2, so this is 2 right here, and the same for all of these circles here. Each circle labeled Z, each circle labeled Y has a radius of 4, so this is 4 here. And each of the circles labeled Z has a radius of R. We don't know what R is. I think that is what we're trying to solve. Each of the circles labeled W or X is tangent to 3 other circles. The circle labeled Y is tangent to all 10 of the other circles, and the circle labeled Z is tangent to 3 other circles. Determine positive integers S and T for which R is equal to S over T. So we're just trying to solve for R, right? We're just trying to solve for the radius of this circle Z. Now let's just draw some things here, right? Like right off the bat, whenever you're given a question with a bunch of circles, just start connecting points to the radii. It always helps. And I'm going to connect it like so to form a bunch of little triangles, right? And what we notice about these triangles is that they're all congruent, right? Because they all have the same side lengths. They all have one side length, which is 4 plus 2, right? So this right here, 4 plus 2, which is 6. And they all have another side length, 4 plus 1, which is 5. And they all have a third side length, which is 2 plus 1, 3. Right? And the same logic goes for this triangle, the same logic goes for this triangle, and the same logic goes for this triangle here. Also tells us something else. It also tells us that this angle is all the same here. Just call it theta, theta, and theta. Right? And I can already solve for theta, right? Because if I use cosine law, I could form an equation involving cosine of theta, right? And I have all 3 side lengths. But we're not trying to solve for theta, we're trying to solve for R, right? So let's try and make a new triangle involving my big Z triangle here, right? I'll draw in green. And what you notice about this is that we can actually just create some variables here, right? Let's just call it R for, well, R. And we notice that this side length right here is R plus 4, right? Because it's the radius of the Z triangle plus the radius of the Y circle. And this side length here is the radius of the Z circle plus the radius of the X, right? So it's R plus 2, right? And if we can solve for, let's say, alpha here, then we could form another equation, right? We can use cosine law again to solve for R. But we don't have this alpha angle here, but we can solve for theta. So let's just do that first and see what happens, right? So let's use cosine law. It'll be 3 squared, sorry, it's orange. I'll use 3 squared would equal to 6 squared plus 5 squared minus 2 times 5 times 6 times cosine of theta. And I'll give you guys a moment to pause on your own and solve for cosine of theta. And what you notice is that cosine of theta would equal to 13 over 25. But it still doesn't change the fact that I don't really care about cosine of theta. I want alpha here. But what do I know about alpha? I know that alpha is equal to 180 degrees minus 4 times theta, right? But if I solve for theta using the inverse cosine function, I get a really weird number, and that I can't really work with, right? So maybe instead of solving for alpha itself, I could solve for cosine of alpha, right? And what we notice about something else is that in a unit circle, let's say in our trig functions, I'll draw one quickly right here. When we are given points, right? And we know that the x values at any point is just cosine. For example, here in this triangle here, let's say I have some random angle theta. My kind of base or x value would equal to cosine of theta. Now, if I turned my theta into 180 degrees minus theta, like so, 180 degrees minus theta, we know that this is actually just negative x, or negative cosine of theta. And using this logic right here, I can try and say cosine, I'll use orange again, cosine of alpha would equal to negative cosine of 100 degrees minus 4 theta, right? Or sorry, 100 cosine of 4 theta, right? So maybe if we could solve for cosine of 4 theta, I could then substitute it into cosine of alpha and use cosine law to solve for r. But I don't have cosine of 4 theta, I have cosine of theta. So how do I turn cosine of theta into cosine of 4 theta? Well, I could use the double angle formula, right? It states that cosine of 2 theta would equal to 2 cosine squared theta minus 1. But at the same time, I also don't have 2 theta, so I have to use 4 theta, right? So let's just replace 2 theta with 4 theta and theta with 2 theta, respectively, right? So let's just create a new equation. Cosine of 4 theta would equal to 2 cosine squared of 2 theta minus 1. And then 2 cosine squared theta, cosine of 2 theta would equal to 2 times cosine squared of theta minus 1. And I could just directly substitute cosine of theta here. I know that cosine of theta would equal to 13 over 25, so cosine of 2 theta would equal to 2 times 13 over 25 squared minus 1. And then this should give me cosine of 2 theta would equal to 113 over 225. I'm going to be skipping a lot of algebra because I feel as if that's not really the goal here. I feel like the goal is mostly the logic rather than the algebra itself, right? And then when we solve for cosine of theta, we notice that cosine of 4 theta would equal to 2 times cosine squared of 2 theta minus 1. Cosine of 4 theta would equal to 2 cosine squared of 113 over 225. 113 over 225 squared minus 1. Cosine of 4 theta would equal to 25087 over 50625, right? So now that we have cosine of 4 theta, we can actually just solve for cosine of alpha, right? Because we know that cosine of alpha would equal to negative cosine of 4 theta. Or sorry, this actually should be a negative right here. And then cosine of alpha would equal to positive 25087 over 50625. And now that we have cosine of alpha, let's just use this triangle right here to form a cosine law equation, right? So let's just draw this out. R plus 2, I'll use orange again. R plus 2 squared would equal to R plus 4 squared plus 6 squared minus 2 times 6 times R plus 4 times cosine of alpha. Right, and we already solved for cosine of alpha here, so I'm just gonna kind of paste it here, right? And then we expand this, and what we notice is that r squared plus 4r plus 4 would equal to r squared plus 8r plus 16 plus 36 minus 12 times r plus 4 times 25087 over 50625. And we can immediately cancel out r squared here, so in the end we're just given 4r plus 4 would equal to 8r plus should be 52 if I distribute the 12 here. Minus, actually that's wrong. That is, no, yeah, okay. And then minus, I'll try and write this number out here. 348 times r plus 4 over 50625. And I'm not going to go through solving r, because not only do I not feel like it, but I also don't think it's that necessary, especially if you're trying to solve problems at this level. I don't think algebra should really be like considered hard. And what you notice is that when you solve for r, it will actually equal to 408608 over 32848, and this simplifies into r would equal to 22538 over 2053, and we're given the question that r is equal to s over t, and this is equal to s over t. So in our therefore statement, we have to write therefore s would equal to 22538 and t equals to 2053. And that is the end of this problem. I hope you learned something and hope to see you soon.